external pre-flight now on the King Air 360. We're going to start with the checklist items, which starts with the cabin door. We're going to look at all of the integrity of our seals. This here is our pressurization line. There's, if I remember correctly, 6 psi system that can come to the door seal as well. This is our electrical line. This is the actual cable that extends the steps. As we pull the door up, the steps will retract, and it causes the cable actually creates tension and a spring. If that ever breaks, that cable will not extend the step and can create a hazard issue for your exit out of the airplane. Now, if you look here on the door itself, you can see how the pins work specifically for that handle. As we go into the locked position with the handle, we've got 4 pins that have to be checked with the integrity of the door seal and structure. Inside of here, you can see the locking mechanism on the piston for the door handle. That is the locking mechanism. To unlock that mechanism, we've got to push on the plunger, then we can unlock, and you can rotate the door handle. You can see the red locking mechanism. There's also, if you get a really close-up view of that, you can see the micro switch inside of that as well, just to that right side. If that micro switch fails or it's not pressing against that micro switch, we'll have a door unsafe annunciator. With the door open and the battery switch on, we can test we can pull this step up and check the light inside of that to make sure that that door is latched with that system. To unlock that, we've got to rotate that handle all the way. There's also 2 locks on the top side with some viewing windows at the top as well. If any of this integrity here of the seals and the pressurization lines fails, they'll get some whistling and a lot of noise back here from the pressurization trying to escape. Of course, we're checking integrity of this door strut, the cables. For air ambulance missions, if necessary, the front cable can actually come loose and be removed from the system itself to ensure that the patient litter and the patient can be loaded without any obstruction inside of the airplane. You gotta go clear forward. There you go. Perfect. Now that's the full operation of the door. Of course, we have to give pre-flight and safety briefings to our passengers as well. As we start on the front side, or excuse me, on the back side of the wing, of course, we're looking for any damage. We're going to check the flaps. This is a pretty new King Air 360. It's about 1.5 years old, so it, as you can see, it's pretty clean. We're looking for any damage, any buckling, overspeed conditions that would have caused the mechanisms to buckle and cause problems. Looking for any loose screws or wear points, silver wear points where it shouldn't be.
Back there too.
Bonding straps. We don't always have to have the nacelle locker locked necessarily, but this aircraft has the locker secured at all points in time with the owner. On the bottom side, I like to come on the outside here and crawl underneath. And of course, as you can see here, the pilots that I'm working with right now decided to harass me a little bit about the bald spots on the tires, but I say that wasn't for me, but you never know. As you can see, we don't have any cords showing. We had mechanics come and take a look at that. Didn't appear to be any issues. We're checking for brakes. This is our squat switch or weight on wheels switch. That arm activates the weight on wheels. The left gear does. Do you recall what the left gear does on that?
No.
I think the pressurization is on this side, but there's several different items. There's one on the right main gear and one on the left, and we'd have to go to the checklist or to the AFM to really determine weight on wheel switch controls what.
It should be the left one.
Underneath, I always crawl under here. The fire bottle gauge is located right on the left side of the main gear structure in the wheel well, and the gauge is on the front side of that bottle. Whenever we're down here checking, we also want to check the rollers for the door closing mechanism. Those rollers actually come up into the brackets and mechanisms which pull the doors closed on the King Air. So we also want to make sure, especially on older models with high airframe hours, that there's not too much play on the doors themselves, that the airflow into the oncoming airstream would create havoc on those doors. While you're down here, you can kind of look at the underneath of the wing, also the bottom of the flaps, make sure there's no buckling or issues, damage on the flaps themselves. Fuel drains, they can be strained or drained. I don't recommend that while you're underneath of the airplane. All right, as we go on the outside of the wing now, of course we're checking the top of the flaps. Any wing buckling, skin damage issues, anything going on that side. We also want to check the ailerons. Now, I've heard some gentlemen that teach that you don't want to move the ailerons as well. I highly recommend it. This aircraft, even though new, has had a couple of problems with the actuators for the trim actuators. So you definitely want to look at your mechanisms inside of here. Which one is this one? Do you know what that
flap
is?
Track.
Okay.
Symmetry.
The flap track mechanism. Here we've got the actual rollers that go forward, and you're wanting to check all of the integrity of that flap. Here's our grounding mechanism as well. We also, if you've set your trim correctly, done the checklist correctly, our trim should be zeroed, and it should be fairly close to zero on this trim, as well as the one on the elevator whenever we're doing the back of the tail on the Preflight on that. We've got mechanisms here. We've got the bushings. These are the static wicks. We can only miss a few of those. Do you recall what our limitation is for the airplane?
It's one per control surface.
One per control surface. So we got one surface, two surfaces, three surfaces, four surfaces, five surfaces. So we can miss 5 static wicks total, but only one per empennage.
Yeah.
So
that's one of the MELs.
5 on this side. We're checking the integrity of the wing. I have seen a few of these that have had hanger rash damage or bird strikes, so you're definitely wanting to check any of the surfaces of that winglet and the covers. The fuel tank and the cap, we do want to make sure that cap is down and secured and flush, and then we're checking the underside of the wing. It's just standard aviation practice and portion that you're wanting to look at. The stall vane, we don't want to mess with it too much, but I do like to see that it moves freely. If at any point in time you have the stall heat switch on.
It's weird that the part of the boot went over this inspection panel right here.
That's I think that's just the black compound that they put on there for the wing boot, where it ties it in. One of the wheels on weight switches also controls the heat to the vane. The switch for the stall vane anti-ice is actually for the plate itself, but the vane is heated anytime it comes off of the wheels on weight switch. Checking the vents, drains, all of that underneath of here. We've already crawled underneath, so we know how to do that. We've got to check it. He's pointing out one other fuel drain. We're not going to drain those today. He's pointing to the vent on that side as well as one of the fuel vents. And if you have a flapper valve that sticks, sometimes you'll get some overflow on some of the King Airs, even coming out of the factory, that can I have seen that happen on some ERs.
You're
Yep, that's the heated fuel vent there, fuel drains. That one right there is the NACA scoop.
Yeah.
Let's go ahead and open up the cowling now. Of course, up here on this side, we've got this is our starter generator. It serves two dual purposes, both to start the engine, to spin it fast enough to get airflow into the engine before we introduce fuel. And then also it serves as a generator. It can only do one or the other. If we forget to shut off the starter and we go with the generator on, the generator will not activate, because the unit can only do one or the other. It can't do both. Of course, inside we've got this is the accessory case, the gear drive accessory case, and it's driving some items in here. This looks like some of the oil pump stuff. We've got some of the oil lines that run forward, probably up to the front gearbox as well. The flow packs located down here on this side, on the end of this line, that's what supplies our pressurization. It's taking air from the heated portion of the compressor section of the engine and allowing that to go through a flow pack, what they call a flow pack, using a Venturi effect to mix ambient airflow to supply enough air to fill the volume of the cabin and supply that environmental and pressurization. We're just wanting to check the integrity of all the lines. We've got oils outs and oil ins lines here. That's all labeled. Of course, this is extremely clean as a fairly new King Air 360. This is our igniter box. Some older models of King Airs would lose the igniters if the pilots would turn them on as soon as they started the engines, and they would sit there and bang without cooling effect or any airflow into the area. So that's something we, as old school as I am, I don't typically recommend, is keeping the igniters on at any time the engines are on. It's just for the takeoff through the landing phase that they typically stay on. By limitation, it's only required for ice, rain, and rock and roll. So icing, moisture conditions, or if you're in turbulence is when we have to use. Let's go ahead and check the oil. The 350 and 360 has an upper access panel on the very, very top. Yeah, you got it, or you want me to reach it?
I can do it.
Okay. He's got a process here where he closes the cowling.
I just normally do it from this side. That's why I'm like.
And that allows him to access, as you can see, go ahead and pull it out. We're going to look at that a little closer, and go ahead and turn it over. The King Air actually shows
It's right there at the one.
gradients in quarts low. So the maximum, how many quarts does the engine hold on the King Air 3 on this dash 60 engine?
14. You can be 4 quarts low.
Okay, so we can go down to 4 quarts. As we can see, we're 1 quart low right now. I always recommend that the airplane stay somewhere between around 2 to 3 quarts low. If you have more than that, as the airplane, especially as the engine gets higher hours, it will blow the excess oil out of the engine and it'll create all kinds of mess. As most seasoned King Air operators and mechanics say, that the engine will find its own oil level over time, and if you don't go above that, most of the time it'll do fine.
I always pull it out. I make sure it's facing down so the oil doesn't drip back the other way.
Agreed. He's eyeballing it in the front of the cowling as he goes in with it, but then once he gets it inserted, then he secures the dipstick, closes the hatch, and then opens the cowling to make sure that everything looks secure and correct on that dipstick, and making sure that the locking mechanism on that is down as well. Don't ever forget to close your latches. I've seen some pilots that have mistakenly left that unlocked and during a run-up and completely ripped the cowling completely off of the aircraft. So, what are you looking at there?
The oil vent.
Okay, we got an oil vent.
And the oil radiator coolers.
Okay, so we've got a cooler there where the airflow comes in, and some of that's diverted through and cools some of that oil down.
And your access panel.
Access panels on the back side. I'll keep repeating. And then on this front side is the oil cooler as well. That's where the exit, we were just looking at the exit. That's the intake for that oil cooler. That is correct. Which way do we want that facing?
With the line.
Yeah, we want, and some of the older King Airs, do you have that on some of your King Airs you're flying?
Yeah.
You see, is it wore out? Do you see some wear on some of those?
The one with salt, with like the paint, we had to have them repaint it.
Yeah.
They had to open up the panel to check because the salt had rusted
Okay.
off, and then they had to repaint where the line was.
So you had to repaint that, and that happens a lot with older King Airs. It will lose the directional arrow, and you've got to have maintenance to resupply that, repaint that line on there, or remark that. Inside of here, of course, we're checking the inside, but you can also see, if you get an angle this direction, you can see I think I just shut my laser off. You can actually see the intake for the engine inlet. There's that pipe. You can see the pipe right there, and that pipe is the inlet for the engine lip exhaust heat. So as that comes forward, that exhaust heat comes forward, and no ice can build up on the inlet and block the intake for the airflow.
Always stays hot.
We always want to check the propellers, of course. This is a free flow turbine, so we're just turning the power section of that Pratt & Whitney engine, not the backside. Checking the propellers, the blades, and we do want to make sure it has that rattle. If it doesn't have the rattle, it's not correct on a King Air. There's the inlet on this side, and this is the engine anti-ice. That is the diverter that comes down and forces the airflow down and into a sharper turn to the intake of the engine. So anytime there's FOD on the ground, it's a normal procedure to have the engine anti-ice on, forcing that airflow into the engine into a sharper turn, that any heavier debris or FOD would not make it into the engine as well. We're checking the cone, the nose cone, the spinner, making sure everything is secured and correct. Here's the locking mechanism. Of course, we want to check this side, and on the back side of this, or on the other side as well, as you can see there, we've got the outlet for that opposite pipe that has gone down through the intake for that engine inlet heated air, and this is the exhaust side. So let's go ahead and open the cowling on this side. Oops, excuse me. And we've already checked the oil. All of our mechanisms for our throttles, power cables, fuel control units, all of those linkages up here are on this side, located on this side of the engine. And so we want to check and make sure we don't have any loose nuts, any missing cotter pins, any wear, anything that's looking like it's wearing and creating a problem in here. Also, this is our, do you know what this one is, Cameron?
This wire?
This line?
Let's see where this is run into, because this is your prop.
This one right here is actually our fire detection system on the heated system, and so it's sensing heat, and that's why it runs around a portion of the engine.
Oh yeah, it doesn't go to the prop. Yep. It goes all the way through.
It's on the back side, and it's reading, and that would actually throw off our fire detection system as well.
I didn't see it going all the way back through there.
No, that's okay. Here's our cables running up to our throttles, props, different things. I think that this is the prop that goes actually up to the governor at the front side of the engine, but you can see what we have here on this side as well. Down here in the bottom, this is the only place that you can find, but this is the fuel bypass, filter bypass indicator right there, which has a red, at the top of that is a red button. If that is extended above that silver housing, then we know that we're in filter bypass and we have a restriction on that fuel filter. Of course, we're checking all the cowlings, making sure all of our Zeus screws are attached. And then at your shoulder level, of course, in here we've got the air-to-air heat exchanger. This is where the airflow enters, and cools down that pressurized air if it's hot outside. We don't want that hot pressurized air coming in and heating up the cabin, and so we want to close that or bypass, we want it to not bypass the air-to-air heat exchanger to where it cools that down with ram air as much as possible, especially at altitude. Of course, this is the exit. This is where the air comes out on the exit side. As we come forward, this is, if you want to stay on this side and I'll come underneath, a couple things we want to check here. This is an indicator of the turn limits. If line service has created damage or turned too far on the nose linkage, we'll bend this piece of aluminum, and we want to make sure that we'll have to have some maintenance inspections completed after that. We want to check the integrity of the shimmy dampener, that we've got enough strut extension. Also, here's the gear up switch or in position switch on this one. We're also wanting to check the door rollers for the mechanical door locks as well, or what pulls those doors up as well. That tube that you just touched right there is the linkage for the steering tube linkage, and that pin, that I've actually seen those locking keys break, and if that breaks, then that linkage can create some mighty strong havoc upon landing or takeoff if you lose that steering linkage. This is a hydraulic system, so we're wanting to check those hydraulic lines. Making sure we don't have any leakage as well, and the general integrity of the gear doors and such. All right, we've completed the nose gear section on this aircraft. The pitot tubes, we're wanting to make sure that the pitot tubes are clear. I'm not sure that we had completed all of those items on the last recording, so this is the alignment portion for the toe functions. If it exceeds limits, it will bend the aluminum on the back side of that. We're wanting to check condition of course, the shimmy dampener, the rollers for the doors, the lights, the pitot tubes up top, making sure that they're free and clear, and the bearings and knee knuckle, or whatever that's called on the nose gill. Torque knuckle?
Torque knee.
Torque knee.
Links.
Good enough. This different King Airs have different sections up here. This is the cargo bay. I've never seen a King Air that actually has a cargo access. Most of them have avionics inside of those cargo bays. So the battery is on top. We've got the battery section here. We've got a ground strap portion where they can catch the ground portion on it when they're fueling, with the auxiliary fuel cap located right there as well. Seals on the cowlings. We've got the boots on the front leading edge, and the air-to-air heat exchanger for the environmental system and pressurization to cool that down. On the underneath, we've got the vents. We've got the outlet for the airflow for the air-to-air heat exchanger. This is also
Access panel.
I think that actually might be some electrical. I've done some on that before, on some electrical access, but that's generally not going to be something that a pilot's going to be performing as well. That vent is for the battery, to give airflow to the battery as well, just in case there was any issues on it. Let's go ahead and open up the cowling on this side. We'll go ahead and check the oil as well. As you can see, he accesses the oil access panel prior to pulling the dipstick, and prior to lifting up the cowling. It just makes it a little bit easier. You don't have to pull that one all the way out this time, since we've already measured on the last. As long as you can tell the oil level on that. As you can see, it looks like, to me, it's probably in that what are you seeing, 1.5 range there?
Yeah.
Okay.
1 to 2.
Okay, good enough. There he's peeking into the cowling to see how the dipstick goes back down into the canister, locking the overhead access panel, and now we'll open up the cowling and take a look. On the right engine, we do have the air conditioner as well, so we have an extra belt to check on this side. Some King Air models on the 90s and such use electric air conditioners, but the King Air 350 and 200 series use a mechanical system and a belt off of the right engine. Of course, we're just checking all of the hoses, flow packs, the accessory drive, making sure we don't have any oil or any loose nuts or any unusual wear going on inside of here that we need to be aware of as well. That should do it on this side. We've already covered most of the items we need to look at in the cowling on the left engine. As we move forward, once again, we're going to look at those locks, making sure that the locks are pointed in the correct direction. I usually also check the cowlings as well. Sometimes the mechanics, even though this may be pointed towards the lock portion, if they don't get that cowling down before they turn the lock mechanism, it can miss the cowling latch on that side. And of course, on this side, we've got the exhaust and the engine lip heat on that side, to where that's pointed into the exhaust stream, which pushes it down to the engine inlet lips, which heats that portion. Over time, you'll start to see this discoloring. We've only got 90 hours on this aircraft, and as you can see here, it's already starting to discolor from the just from that heat coming from the running engine. We're going to check the propellers, the spinner, making sure we don't have any FOD damage on any of the spinning mechanisms for the engine here on the front side. So that is the heated lip boots, yep, for the prop heat itself. That's electrical on the propellers, pneumatics on the boots on the wing, but electrical on the propellers. That keeps the inner portion of the boots clear. The centrifugal force on the outer portion of the wing, on the outer portion of the propeller should keep the ice off. I always recommend if you're into heavy ice in the King Air, that you go to high RPM, which that centrifugal force will help to keep the outer edge of the propellers clear and allow it to not build up as big of ice material prior to flinging that off, which can damage the fuselage as well. Of course, we're checking the lock mechanism on this side of the cowling, the inside of the exhaust, as well as the outflow for that intake heated lip. It's a good check.
I was like, I forgot to look down.
Let's go ahead and open the cowling on this side. And I do believe we missed one portion on the other side as well. I don't believe we can actually access the
other side. It's easier.
The filter bypass on this side. It's very difficult to see on the inboard on this right engine, but we can access that. We'll have to go back over and check it. Fuel filter bypass is accessible typically from the inboard. We will, if we can't get a good view on that, we'll go back to that side. That's okay. We're checking all of the linkages, nuts, cotter pins, systems as well. This is the cooling access we talked about on the other cowling, the NACA scoop, which draws air in for the cooling of the generator. Because of the high electrical output, that can get very, very hot, and so it has a cooling mechanism on that system to be able to keep that electrical system fairly decently thermally cooled. As soon as we get everything latched, we'll check the front of the wing here underneath. You can go under there, but I typically wait until I get on the back side, but you can go wherever you want. This is the APU, auxiliary power section, where we can plug in the GPU portion of that. I shouldn't say auxiliary, that's ground power. So GPU section on this, where that plug would go into. And of course, we've got the fuel drain behind. We've got a gravity line drain, that's primarily maintenance, and then we've also got a NACA scoop underneath and a fuel vent. Is any of that heated?
This is.
Yep, the fuel vent on that portion is heated.
This panel though, it's fine,
And of course we're checking the front of the boots, making sure that the boots are in good condition. It is acceptable to find areas that have been repaired or patched. We check the fuel cap as well on top, which appears to be closed and latched and sealed. That looks good. Checking the integrity of the lights, the clear cover on that, the plexiglass. Also on the winglet, everything's very smooth and very clean on this airplane. And also the movements of the ailerons and the static wicks, as we've already discussed. We're also checking those pivot points, grounding straps, turnbuckles, nuts, plates. This is the drive mechanism here for it, up inside of that for the aileron itself.
Manual trim tab.
What's manual trim tab mean?
Maintenance moves it.
Yep. We can't move that, but they can adjust that slightly if it's quite a bit off on your trim for the aileron portion. Checking the flaps. The flaps, if they're fully retracted, should still have some play. If you get a really good mechanic that finds the exact limit of that track, some of those would have less play when they're retracted, but generally you do not want them to go beyond, because they can damage some of the motor or some of the linkages on it. You've got the actuator tubes, the rollers, the track mechanism. We're of course looking for that buckling, checking to make sure that that's locked. If that, per the operation, that's what they desire. If you want to go ahead and go underneath, I like to go on the outboard side to find that fire extinguisher on this side. Clear up on the outboard is the fire extinguisher portion. That's showing the level of the fluid. Actually, I think that's a carbon. I don't recall. Do you recall what what's in the fire extinguisher itself?
Not the fluid. I'd have to look that part up.
It's some sort of gas, but I don't remember what it is.
Pressure
But we do want
based on the
to
outside air
look like it.
temperature.
Yeah. We've got the uplock switch indicator that shows that it's in position, and then we also have at the back of the gear, we also have the weight on wheels switch once again that shows the position, and we're checking the rollers for the doors. Of course, we want to check the integrity of these doors as well. All the mechanism linkages, bolts, making sure there's no uncommon wear. And as we finish off, we've got our actuators for the flaps. Also, if you look clear up there, I think that's a position indicator on the flap itself. So this is where it's reading your positions off of the right inboard flap. Wanted to check the connections, bolts, flaps, flap tracks. And of course, as we move back, looking for any damage on the fuselage itself. The RVSM on any airplane has a very wide area for the static. No protrusions or anything can be in this area. This is our static ports. I believe one goes to the pilot and one goes to the co-pilot, and on the opposite side the same. Dual strakes are required for flight above in the flight levels 290. I think 190.
Yeah. 19,000.
It's dual strakes.
Yeah.
And some of the older models did not have the dual strakes, and so that I believe that was a raised-back. It might get some pushback on the internet from some of that, but I believe that was a raised-back function. Of course, the strakes are just a smaller piece of metal. That's a no-push area if you are moving the aircraft. We've got some maintenance areas with some servos for your autopilots back here, if I remember correctly. Also some areas if there's a maintenance portion up underneath of the belly that they call the hellhole on the airplane. So that's maintenance is about the only people that I've ever seen get in there. It's pretty tight. On the aircraft, on the rudder, we're going to check the turnbuckles or the drive mechanism for that trim portion for the rudder as well. and anything you can see on the pivot points and damage areas. It's got a very large rudder on the King Air 300 series. As well, we're checking the lights, the elevator, the static wicks as well. Also on the trim tabs, if we set the trim tab correctly on the Preflight, we should have that fairly equal on the elevator trim as compared to the elevator itself. Moving over to the left side, once again, we're just checking those turnbuckles and actuators for the trim tabs, static wicks, condition of the elevator, boots, the empennage, and coming down the rudder, the vertical stabilizer, and once again on this side, as he's pointing out there, I personally always check the serial numbers and plates and such because I am full-time contract. I always am making sure that I have access to some of that information. We've looked at some of that as well, but also got the tie downs. I have seen damage on the tie down areas from poor mechanical jack stands. So you want to make sure and check that as well on the underneath. That is the relief tube there on the bottom portion of that. The relief tube is not something we probably want to talk about on the internet. So that's a biofunctional aspect of piloting. On the as we come forward, we've got the static ports, and
relief tube, and one's the pressurization relief tube.
Oh, it is nice. So that's a pressurization relief tube on the rear one.
Yeah, the rear is pressurization, and the little one.
The little one up front is the bio relief tube. So
the one you don't probably want to touch with your tongue.
Yep, you don't want to do any cleaning on it specifically. And that completes the exterior Preflight on the King Air 360.